We're going to look at a couple more examples for writing equations for parallel and perpendicular lines. And these examples are worded very similarly to potential test questions. So the first case we'll look at is a parallel line. We're going to write the equation of the line meeting the following conditions, then graph both lines. Any of the equations, any of the forms for the equation of a line is okay. So what line are we looking at? We want one parallel to x minus 2y equals 5 and going through negative 1, 4. This negative 1, 4 is on our new line, and we're going to work with the reference line here, x minus 2y equals 5, to figure out our slope. So let's review the procedure for working problems like this. The first thing we need to do is find the slope, m. And I'm going to get that by rearranging that reference equation. There's more than one way to do this. This is just the method I'm going to use today. I'm going to put this in slope-intercept form. So I need to move the x. So negative 2y is a negative x plus 5, and then divide by negative 2. So we'll have y equals a 1/2 x minus 5/2. What is my slope? Well, the coefficient of x is the slope of my reference line, and that's 1/2. So the slope of my parallel line is also 1/2. Remember that parallel lines have identical slopes. Well, I'm halfway there. I'm supposed to now write the equation for the line through negative 1, 4, and with this slope. I'll start with the point slope form, and that's always our next step. So y minus y1, where y1 is the coordinate 4, is equal to m, 1/2, times x minus x1, and that's our coordinate negative 1. So let's go ahead and substitute in. Y minus a 4 is equal to a 1/2 times x minus a negative 1, or plus 1. Now, it's perfectly fine to stop right here with the equation of the line. The directions said that any form for the equation of the line was okay, so we could stop there. I'm going to go ahead and rearrange this and write it in standard form. So we'll have then, let me circle this one because that's an okay answer. We'll have y minus 4 is 1/2 x plus 1/2, just using our distributive property. Let's go ahead and multiply everything by 2. So 2y minus 8 is x plus 1. Now ordinarily I write out all that multiplication, but I'm trying to keep some of the clutter off the page. I always recommend you write out all those intermediate steps. Let's get x and y on the same side. And I'm going to do that by putting them on the right because I want the coefficient of x to be positive. So I'll subtract the 2y and subtract the 1, and we'll have a negative 9 is x minus 2y, or we could write x minus 2y equals negative 9. Let's take a moment, if I can get this to fit here, and compare these equations. Notice that we have x minus 2y, and in our reference line we also have x minus 2y, but that constant on the other side is different, and that's very typical of parallel lines. So let's see, here we rearranged, even though it was optional. Now we need to graph those two lines. That was the second part of the instructions. So let me get some graphing paper here. And take a look at this. Now my graph is not perfect, but it gives us some nice straight lines to work with. So we had the point negative 1, 4 for our parallel line. So I'm going to go ahead, this is our x-axis and our y-axis, and graph that point, negative 1, 4. And I'm just going to count off a couple more points before drawing my line. Our slope is 1/2, so that means that we will go up 1 and over 2. And we can do that a couple of times. And there is our new line. That was x minus 2y equals a negative 9. Now our other line, and I will just write that equation here, was x minus 2y equals 5. Let's find a point on that line, and then we can just count off with the slope. I'm going to choose y equals 0. And if I do that, I'll end up with x minus 2 times 0 equals 5, so x equals 5. So there's a point here at 5. Let me write that point down, 5, 0, 2, 3, 4, 5. And again, our slope is a 1/2. So we can just make a couple of points and connect them. And notice how those lines never cross, especially if we had a nice straight ruler. And they're running parallel to each other. Now that we've looked at a parallel example, let's look at an example for perpendicular lines. And the example we're going to look at, again, is write the equation of the line meeting the following conditions, then graph both lines. Any form is okay. We'll go this time perpendicular to 2x minus y equals 7 and through the point 1, negative 3. So once again, our first move is to find our slope. So I'm going to rearrange this reference line, 2x minus y equals 7, into slope-intercept form. So negative y is a negative 2x plus 7, and changing all the signs, y is 2x minus 7. So the slope of my reference line is 2. But remember that for perpendicular lines, slopes are negative reciprocals. So I'll just abbreviate that. That means I need to flip this 2 over to get a 1/2, and then I need to change the sign. So the slope of my perpendicular line is negative 1/2. Well, now again we go to the point slope form. So y minus y1 is m times x minus x1. And we'll have a y minus a negative 3 is a negative 1/2 times x minus 1. And again, we can make that positive. And we can stop here because any form is okay. But once again, I'm going to rearrange and put this in standard form. So we'll have y plus 3, using our distributive property, is negative 1/2 times x minus a negative 1/2 times 1. And that gives us a negative 1/2 x plus 1/2. Let's multiply everything by 2. So 2y plus 6 is a negative x plus 1. And I'm going to subtract the 6 and add the x. And we'll have x plus 2y is a negative 5. So we have our equation in standard form. And let's look again at graphing both of those lines. We'll start with the x plus 2y equals negative 5. We know that that has the point 1, negative 3. So that one's right here. And we have a slope of a negative 1/2, so up 1 and over 2 to the left. up 1 and over 2 to the left, and there's our perpendicular line. X plus 2y is negative 5. And let's graph our original, which was 2x minus y equals 7. And again, let's pick a point. This time I'm going to choose x equals 0. If x is 0, then we have negative y is 7, or y is negative 7. So we've got the point 0, negative 7 over here in the scratch work. So if x is 0, down 1, 2, 3, 4, 5, 6, 7. And we have a slope of 2 for that line, so we'll go up 2 and over 1, up 2 and over 1. And you can see that these two lines cross at a right angle. That's how they look when they're graphed. Again, these are very typical of how test questions are worded, so if you have any questions, I would really recommend that you talk to your focus group teacher.